Here's the next question, number 26. The maximum value of A such that the matrix, we have a 3 by 3 matrix here, -3, 0, -2, 1, -1, 0, 0, A, -2, has 3 linearly independent real eigenvectors is, so we have our 4 options. The 4 options correspond to the value of A. So let's try and work it out using the fact that it has 3 linearly independent real eigenvectors. So let's start with the matrix given to us. We'll call that A. A is equal to -3, 0, -2, 1, -1, 0, 0, A, -2. So since this is a 3 by 3 matrix and they have mentioned eigenvectors, so the first thing we do is to find out the characteristic equation for A. Characteristic equation for A. Now this is determined by mod of A minus lambda I is equal to 0. That's det. Det of A minus lambda I is equal to 0, where lambda corresponds to the eigenvalues and I is an identity matrix. So now let's apply this to the matrix here. So A now becomes -3 minus lambda, 0, -2, 1, -1 minus lambda, 0, 0, A, -2 minus lambda. And the determinant of this is equal to 0 according to the characteristic equation. Now let's find the determinant of that. Now if you find the det of the characteristic equation, we will obtain -3 minus lambda into the multiplication of those two there, -1 minus lambda, -2 minus lambda, minus of 2A, minus of 2A is equal to 0. Now let's take the negative signs out. We can resolve this further and write it as 3 plus lambda into 1 plus lambda into 2 plus lambda plus 2A is equal to 0. Now the question tells us that the matrix A has got 3 distinct eigenvectors. So if it has 3 distinct eigenvectors, 3 linearly independent eigenvectors, linearly independent real eigenvectors, then we would have 3 distinct eigenvalues of A. So I'll write that fact down here. If A has 3 linearly independent eigenvectors, then that implies that A has 3 distinct eigenvalues. So you will observe that in this equation here, we have 3 factors and each factor corresponds to one value of lambda. We'll have lambda is equal to -3, lambda is equal to -1 and lambda is equal to -2. Now let's consider just this portion here and let's take that as f of lambda is equal to 3 plus lambda into 1 plus lambda into 2 plus lambda. So in this equation here, the roots are -3, -1 and -2. So just keep that in mind. So if we were to apply this here, substituting the expression 3 plus lambda, 1 plus lambda, 2 plus lambda as f of lambda into the characteristic equation there, we'll get f of lambda plus 2a is equal to 0. So let's take that 2a to the other side. We'll obtain f of lambda is equal to minus 2a. So let's try to visualize this in terms of a graph. So if we are to draw a graph here, we have our roots at minus 3, minus 2 and minus 1. And since it has 3 factors along with a constant of 2a, the graph should resemble a curve that's something like this, where it has a maximum point and a minimum point. Let's call the maximum point as Q and the minimum point as P. We'll say P is x1, y1 and the maximum point is x2, y2. Now the key here is that we need to find out what y1 and y2 are because they correspond to the values. This is the minimum value and this is the maximum value. y1 is the minimum value of f of lambda and y2 is the maximum value of f of lambda. So that is what we need to find. Now I'll just write it in terms of x so that the solution is a little easier. So now we had f of lambda is equal to lambda plus 1, lambda plus 2, lambda plus 3. I'm going to write it in terms of x. F of x is equal to x plus 1, x plus 2, x plus 3. If we expand it, we'll obtain x cubed plus 6x square plus 11x plus 6. So this is f of x. Now since we are supposed to find out what the minimum and the maximum values are, we have to find the derivative of this equation. So we start with f dash of x. F dash of x is equal to 3x square plus 12x plus 11. Now in order to solve and find the value of x, we have to equate f dash x is equal to 0. So that implies that 3x square plus 12x plus 11 is equal to 0. Now we can solve this by using quadratic equation, or since anyway we'll be able to use our calculators, we can easily find the roots and the values of x. So x comes to minus 6 plus or minus root 3 by 3. These are the two values of x. Now the next step is to find out what f double dash of x is. Now f double dash of x is 6x plus 12. Now to find the minimum and maximum value, we have to substitute the value of x from f dash of x into f double dash of x. So let's take each of these two values at x is equal to minus 6 plus root 3 by 3. F double dash of x equals, now we're substituting this value here, 6 into this plus 12. I'll leave that solving to you, that part of the solution to you, since it's just arithmetic. We'll obtain a value of 2 root 3. Now the value 2 root 3 is greater than 0. So when the value is greater than 0, that implies that it is a minimum value. Similarly, at the next point, x is equal to minus 6 minus root 3 by 3. We substitute it into the equation 6x plus 12. F double dash of x will result in minus 2 root 3. Now minus 2 root 3 is lesser than 0. So that implies that it is a maximum value. So now that we have the minimum and the maximum value, the next step is to find out the value of a. And we can do that by using the range of f of x. Let me just grab another sheet of paper and we'll continue. Now that we have the minimum and the maximum values of f double dash of x, we know that at the point of x is equal to minus 6 plus root 3 by 3 and minus 6 minus root 3 by 3, we have our minimum and maximum values. So what we have to do is, I'll write down the points again. It is minus 6 plus or minus root 3 by 3. So at x is equal to minus 6 minus root 3 by 3, we have a maximum point. And at x is equal to minus 6 plus root 3 by 3, we have a minimum point. So we will be able to find out the range of f of x. So we have to substitute x into the function f of x and find out the value. So f of x is the equation x cubed plus 6x squared plus 11x plus 6. This is the expression that we wrote down. So what we have to do is substitute this value x into here, into this expression, and find the maximum range, and you will get 2 by 3 root 3. Similarly, you substitute this value into the equation and you will find the minimum value, minus 2 by 3 root 3. Now, we saw that f of x or f of lambda, in fact, I'll write that down here, f of lambda is equal to minus 2a. We saw that in the previous step here. There, f of lambda is equal to minus 2a. Now since I have written it in terms of x, it's f of x is equal to minus 2a. So let's substitute this here. So we have minus 2 by 3 root 3 minus 2a, 2 divided by 3 root 3. Now we are to find out only the maximum value of a. That's what the question says. It says we need the maximum value of a. Now if we eliminate the negative sign, we would have to flip the equations around. You know the inequality rule, that if you divide by a negative number, you will have to flip the inequality symbols. So this gives us 2a is equal to 2 by 3 root 3. That's because we are taking only the maximum value. So the maximum value would be positive. Now we can solve this further and we would obtain the value of a as 1 by 3 root 3. Now this is our final answer. And this matches option B. Well, this is the entire solution and I hope it has helped.